Graphs are used to visually depict a set of data. The charts that the researcher selects need to represent the data that they have gathered. There are different types of graphs that display certain differences or relationships between two sets of data. When presenting a graph, there are certain aspects that the researcher needs to include in order for the data to be shown correctly and clearly. The graph needs to be titled, the axes must be labelled, all units must be labelled if the graph is representing measurements. If the graph represents variables, then the independent must be on the x-axis and the dependent on the y. To make the data condensed and easy to read on a graph, then the researcher can round the data up or down to 2 decimal places on each value. Figure 7 shows a raw data table. When presenting and evaluating data, the researcher can put the raw data in an appendix so that anybody that wants to look at it can. However, Figure 8 shows the summary data. It conveys the statistical tests that are done to evaluate whether the research and data collected is trustworthy. Therefore, this data is the most important as it highlights and backs up the points that the researcher is trying to make. It goes in the actual report, whereas the appendix will be at the end of the report. The raw data is usually put in 2 columns as seen in Figure 7. A researcher could present their data using a scatter plot graph. A scatter plot graph shows the relationship or differences of 2 sets of data. The data can have a positive or negative correlation. From this graph, the researcher can gain the R value and the P value. The R value shows the magnitude and strength and direction of the correlation, whereas the P value, if below 0.05, states if there is a significant relationship within the data. Within these examples, Figure 9 shows the graph with no line of best fit, but in Figure 10 I have added a line of best fit to convey a visual representation of the correlation in this dataset. Next, a researcher could use a line graph. The line graph can convey the comparison or differences between 2 data sets. Within this graph, the researcher can plot a standard deviation bar to establish the values of both sets of data compared to the mean. Shown in the standard deviation bar on the graph, the standard deviation values range from 1.4 to 4, with the mean for the static sprints being 2.72, with a standard deviation of plus or minus 1.33. The mean can be shown straight down horizontally in the middle of the standard deviation bar. Highlighted in blue at 7 seconds, this could be known as an anomaly, as it's different to the other scores. It's not in close relation to them. The anomaly could have caused the spread of data to be larger, causing the standard deviation to be higher. Whereas because the flying sprint starts mean is lower, the data values are close to the mean due to the small standard deviation. A bar graph can be shown to present data as well. A bar graph simply states the results that the independent variable had on the dependent variable. So in this example, the dependent variable was the skinfold caliper scores, because that's what the researcher was measuring. However, the independent variable is the participants, as the researcher changed the participant to see if there were any changes in the score. Therefore, the graph represents what it's supposed to. Next is a box and whiskers plot. So a box and whiskers plot highlights the range, medium, upper and lower quartile range, and outliers can be notified on the box and whisker graph to show the variation of the dataset. So the medium of a dataset is represented in the middle of the graph, whereas the upper 25% of the data scores are presented in the top half of the graph, and then the lower 25% of the data, so the lower quartile, is represented in the bottom half of the graph. The upper and lower quartile range can be distinguished by the line that is down the middle of the graph. As to the bottom half of the median, that is the lower quartile, and then the top half of the other side of the median is the upper quartile. The cross in the middle represents the mean of the dataset. Histograms are used as visual representations of group frequency distribution, which eventually can represent the normal distribution curve. But due to the small data set we had, it is less likely to see the normal distribution curve. So figure 15 doesn't actually show the normal distribution curve. I'll explain in more detail later about the normal distribution curve, but it's to do with the standard deviation and the spread of data, and it would normally be a bell-shaped curve, and as you can see by figure 15, it does not look like a bell-shaped curve. The graph doesn't go up and round and down. So figure 15 does not represent a normal distribution curve.